It's hard for me to even, I should know the answer to this by now as well, but I don't. Oh, Piper's showing hers. What is that, Piper? Oh, Emily, that's a sword there.
Yeah, these are charms.
It's charms there. That's so cool. I used to do charms too. That's awesome. And then Emily, can you give us the backstory of that sword that you had? That was so cool. A piece of Odessa meteorite. Oh my gosh. That is so cool. Y'all are way out of my league here. I love it. Your necklaces, I love it. Yeah, it's hard to choose just one thing. If I'm choosing something like sentimental, it would be different than something like valuable. Something really valuable that I own that I really love is my flour mill and my coffee machine. Those are like my two favorite things. I like to mill my own flour, and I'm really proud of that. I love the machine that I have. But for sentimental stuff, you know, I don't know. Let me read more of y'all's comments here. It's a replica of the Master Sword. That is so cool. I love that. Okay, anything else? Yes, Alyssa, that's true. Something, probably the favorite thing that I own, if you include a baby, is the baby I'm growing right now. And probably some baby stuff once I get it. I still need to get some baby stuff. Okay, you're addicted to Etsy. I love it. I love it. Okay, cool. Y'all keep on the comments here if you have anything else to add of your favorite thing that you own, or that may be something that you've bought this year. Just something like show and tell, something that you really, your favorite thing. Your cat. Yeah, okay. If we're including animals, then definitely my dog. I didn't think about that. Yes. Yeah, okay, I love it. Okay, a couple things here. You're invited. There's a couple invites for today. If you have never joined my classroom, besides live class, so live class doesn't count. Besides live class, if you've never come into my classroom this semester before, you're invited to join today at 2 p.m. just to say hi and to break the ice. So if you're a new student, you've probably never joined my classroom. And then there are some of you that have never joined my classroom, maybe because you don't really need to, or maybe because you're a little bit shy and you don't want to, but you're invited to join today at 2 p.m. just to come in, break the ice, say hi, and then you can leave. But I'd love to see you guys at 2 p.m. today. And if you've come before, but you want to come in, that's also okay too. But I really want to see some new faces today. And then also, so think about this for you. If you are behind, if you see red on any assignment from Unit 1, okay, if there's anything where you have a 0 put in because you're behind pace and it's in Unit 1, then you're invited to stay after class today, or to join at 3 p.m. to get some of it done. Okay, so I want you to challenge yourself to come in if you normally don't, because if you're behind, if you're on pace, that's great. But if you're behind, you need to be coming into my classroom to get some help whenever you need help. And I know it's a little bit challenging, but at the same time, I'm going to be nice to you. I'm not going to be rude to you, and I'm going to help you get your stuff done quicker. So it's a really good challenge for you to be like, okay, I can do this. I don't know if any of y'all are the type of people who hate calling the pizza person, where your mom's like, you need to call them, you need to order the food, or any of you guys like that, where you don't want to make the call or whatever? Yeah. Okay. I see some of y'all. I need to see some yeses from people in here who normally don't come to my classroom. Y'all are like, I don't even want to put it in the chat. I don't want to talk at all. Okay, I used to be like that. I don't know if y'all know this, but I was homeschooled growing up. So I was really, really, well, it's not true for every person who's homeschooled, but I struggle with being really shy. And now I'm kind of the opposite. I've really learned, it taught me how to okay, I can do this, and people don't think weird of it. It's only in my head. And I learned to just start making phone calls, start actually getting out there a little bit more. And I'm so glad that I did, because nobody else thinks anything of it except you. It's not like you sound weird when you're ordering the pizza. They get orders all day, right? Same thing with me. It's not going to be weird for you to join, and it's going to be really helpful for you to have a teacher who can help you all year. So come to my classroom. If you've never come before, come at 2 p.m. And if you're behind on Unit 1, come at 3 p.m. And if that's both for you, then come to both if you want to. And I'm awkward too. So don't worry, you're not going to be the most awkward one. And if you are, or you're not going to be the most awkward one, I don't even think that way at all. So just know you're invited. Next thing, this is a application thing. I'd like you guys to download one of these for the periodic table. Again, here's the slides. You can go to this slide and you can click on it. It's like a link. Or maybe I can put the link in here, but that will take me a minute to do that. Does someone want to put the links in for me for those two? Download one of these. Okay, there's a colored version and a black and white version. If you have a printer, I'd like you to print this periodic table if you can. But if you don't have a printer, it's totally fine. I'd like you to save it to your Chromebook so that you don't have to like keep, I don't know, looking things up or figuring things out. Thank you so much. Okay, so Megan and Alyssa put in the links there for those links right there. Thank y'all so much. So there's a colored version, a black and white version. It's the periodic table, but you're going to use this all year. And so go ahead and download it now and let me know when y'all are ready. So y'all give me like a thumbs up or something in the chat once you've downloaded that. Okay. Awesome. Thank you, Megan. It takes a second to download, so no worries. Anybody stuck like they don't know how to download it? You can click like the save button and it'll save it to your computer, I think. And you can choose like where you want to save it. You can also upload it to your own personal Google Drive if you want to like organize it that way. Awesome. Thank you, Alexis. Perfect. Emily's got it. Perfect. Awesome. Yaylin is on top of it. She's already printing it. Way to go. Catherine said thumbs up emoji. I love that. I feel that. Emery, thank you so much. Anybody else need a minute to download it? You're going to be glad you did. Awesome. Kayla's got it. Thumbs up emoji. I love it. Okay, cool. All right. I just want to give you all a second. Yeah, I totally get it. I just copy and paste them. Yeah, when you're on the computer, it's harder to do emojis. Y'all should be, if I send you guys an emoji, you should be proud. You should tell them I would love the affirmation because it takes a little bit more work to send emojis on a computer if you haven't noticed. So if you ever get like an email or a text from me with emojis in it, just know that I put in that little bit of work for you. So yeah, computers can make it hard. That's totally fine, Emily. That's totally fine. And if you don't have a printer, it's totally fine. Like you can use it on the computer. I think that sometimes having it that you can interact with is better for some people, but it's totally okay if you can't print it. Yeah, and Megan's got all the tips there. I love that. Okay. Oh, this did not show up appropriately, but that's okay. So we're going to talk today about some stuff about the atom in general. And it's really important to pay attention to this because it's like the basics. And then when we build on it later, we're always going to be referring back to this stuff. And so it's really important that you're like process this and you're like, okay, I understand. I actually know what an element is. I know what each thing on the periodic table means. And it's easy to forget that stuff. And so this is really important to just kind of process and understand. So the first definition here is what an atom is. And I bet a lot of y'all already know, like, okay, I think I know what an atom is, right? But an atom is like the smallest component of matter that still contains all the properties of an element. So it's like the building blocks of everything in the world made of matter, right? You can break an atom apart. Does anybody know what happens when you break an atom apart? What happens if you break an atom apart? Any guesses? Has it been done, or what do you think happens? Just curious. Creates other tiny atoms. That's a good theory. Not exactly. It's okay, Autumn, no problem. Any idea what happens when you split an atom? Think about hydrogen, actually. When you split, there are scientists who have split open. Okay, Allison, I love that answer. Yes, the parts inside are called quarks. Like the protons and the neutrons, whenever you break them apart, they're actually made of that. Yes, and when you split an atom, the result is so powerful. There's so much it's so difficult to do it. It takes so much energy. There's so much energy and attraction within an atom that if you do split it, it creates so much energy that it creates an explosion, right? And actually it creates what we call an atomic bomb. It's like really serious, right? An atom does not like to be split. And if it splits, the energy is so powerful that it creates a huge explosion. An atomic bomb or a hydrogen bomb is what they've done, right? So you can break apart an atom, but it really is like the building block for everything else. And then within an atom, what do you guys think the red and the orange is in the atom right here? When you look at this picture of an atom, what is the red and the orange there? Yeah, isn't that crazy? A tiny atom can do that. It's crazy. Great job, Allison. The red and the orange inside the atom are called protons and neutrons. And then the blue circling around the atom are called electrons, okay? So a proton is positively charged, okay? Positively charged. And the protons are very, very important. The number of protons in an atom is unique to each element. It's like the defining factor of an element is how many protons it has. So you can maybe like star that if you ever take notes, like star, like the number of protons is very important, and I'll explain why in a minute. Neutrons are also in the nucleus. They're neutrally charged. So they don't have, neutral means zero. They don't have a charge, but they're just hanging out in the nucleus, okay? And they weigh about the same. One proton and one neutron, they weigh really, really, really small, but they weigh about the same amount, okay? And then electrons are negatively charged. It's really important to know that electrons have a negative charge, and they orbit around the atom in these certain energy levels, okay? So you can see here, they're orbiting around the atom, and they're orbiting because they're attracted to the protons. They actually want to get close, and they're sticking in that orbit because they are attracted to the protons. But something about them is they don't weigh very much compared to protons and neutrons. So their mass is negligible compared to protons and neutrons. We don't even really have to weigh them because they are so tiny and they move so fast. It's crazy how fast they move. As scientists, we've never been able to pinpoint where they are exactly because they are moving so fast, and they are so small and light, and they don't weigh very much, but they're very powerful. So it's like chemistry is cool because you're dealing with like this other world. Like we don't understand that world at all compared to what we will know maybe in 100 years, but it's this really small world, and this is like the basics of that world right here. Okay, let's see. I think I skipped a slide. Okay, so really important to know, if we ask you for the mass of an atom, the mass is the protons plus the neutrons. So what do you think the mass of this atom would be? The mass is protons plus neutrons. So we need to count all of the protons and all of the neutrons there, and they're kind of hiding around. Let me see if I can count. I actually haven't counted this yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm counting 13 in that middle part there. Are y'all counting 13? Natalie got 13. Kayla counted 13. Okay, so if I ask you for the mass of an atom, you just do the protons plus the neutrons. And the answer is 13. And the unit for that is, I'll put it in the chat, AMU, or atomic mass unit. That is like the unit that goes with it. It's called AMU. So that's how you find the mass of an atom. So I want to do a challenge with that. I think we'll do it in just a second. The next thing is the atomic number. So when you have a periodic table, the number on top is called the atomic number. The atomic number is how many protons an atom contains. It's the exact same. So if an atom has 6 protons, its atomic number is 6. Each element has a certain number of protons that never changes for that element. So if you change the proton number, the entire thing changes. Meaning like it doesn't you can't do that. The proton number identifies the element. You can change the neutrons, you can change the electrons, but the protons should stay the same. Although scientists have figured out how to add in more protons. And guess what happens when you add in more protons? the element changes. And so guess what they've been trying to make with it? They try to make gold because gold is really valuable, right? And they have actually done it. So they take one element, they're like, oh, I need to add in 5 more protons to make this gold. And they will put it in this huge, I need to show a picture of this huge machine. And they can technically add in more protons and it will turn into gold. But the energy that it takes to do that is so much energy that it costs more than what the value of that gold is anyways. So it's just cool. It's just a cool factor thing. It's not really to earn any money. It's just like, we can do this, so we're going to do it type thing. So you should know, for you, the proton number never changes, and it's the same as the atomic number, and it's always shown on top. Atomic number is the same as the proton number. It's always shown on top. And then when you have an element is just everything that's the same type of atom. So for example, if you have hydrogen atoms, that represents the element hydrogen. It means that they're all the same type of atom in that element. And they're all listed on the periodic table. So there are 118 different elements now that we have discovered, although I think in your lesson it says 117. I think it's a little bit outdated, so make sure you read that carefully in your lesson. But there are 118 elements that we've discovered. Those are all just different types of atoms. It's like different ABCs, right? So each atom represents an element if it's a certain type, and the proton number is what makes it a different type. So there are 118 different types, 118 different proton number. Okay, so practice real quick. What is the identifying number for each element based on the number of protons? What is that called? Yes, even they are wasting a lot of money to get that gold. What is it called? The identifying number for each element based on the number of protons. Any guesses on that? It's an important definition from before. Yes, great job, going back. The atomic number is the identifying number based on the number of protons. It's very important, great job. No, it's okay, there's a lot of information here. So atomic number is how many protons something has, and it identifies the element. Great job on that. Okay, next challenge. Take a second on the periodic table that you just downloaded, or if you did not download it, you can use an online one. Here's an online periodic table I'll send in the chat if you want. But find chlorine on the periodic table and tell me the atomic number of chlorine. So find chlorine. I'm going to give you all a second before I look at the chat. That way everybody has a chance. I don't want to tell you all the answer yet. I want to give you all a second. Some people go faster than others. It's totally okay if it takes you a second to do this. But go find chlorine and tell me what is its atomic number. Okay, so I'm seeing some responses there. All of y'all are correct. Great job on that. Now tell me, so that's the atomic number of chlorine. How many protons does chlorine have? How many protons does chlorine have? Great job. Okay, it's the same, right? The number on top is the atomic number, and that is how many protons it has. It's going to be the same, okay? And you'll see some questions where you have to answer the same if they ask you atomic number and proton number. So great job on that. Okay, let's see. Did I do another? Okay, what element is this? So remember that the red here is the number of protons. So we need to figure out what element this is. What do y'all think? Okay, remember, y'all are so close. Remember that the number of protons is what matters, not protons. Protons plus neutrons tells you the mass, but protons tells you the element, right? So we need to count the protons. The protons are the ones with that little positive, so they look kind of red, right? So count the red ones because those are the protons. So I'm seeing how many protons? I'm seeing 6 protons, right? So there are 6 protons. You see those 6 red circles? So we go over to the periodic table, we find element number 6, and it's carbon, okay? And it's a little confusing because some of y'all counted the total on the inside. The total is how much it weighs. It's its mass. But the protons are what the element is. Does that make sense? Sometimes practice is what really irons things out, because like you say something and you're like, oh, that makes sense. But then when you practice, you really kind of understand it. Okay, so you count how many protons and look up the atomic number on the periodic table. And we figured out that the element of this is carbon. Okay, and then the mass that you see on the number you see on the bottom of an element is called the atomic mass. So I want y'all to pay attention. This is a little bit different. The atomic mass is the average mass. So you're averaging everything of all of the isotopes of an element based on their abundance in nature. Okay, so we're going to break that down in a second. But you need to know that the bottom represents the atomic mass of the element. We're going to introduce what an isotope is, and then it'll make a little bit more sense. Y'all may have heard of the word isotope before. Okay. So let me ask y'all, what do y'all notice is in common about these three elements here? Or these three atoms, I'm sorry. What's a commonality between all of them? Great job. Okay, I'm seeing it. Natalie and Catherine and Sang all have said they all have one proton. So what element is this? If it all has one proton, if it all has one proton, then what element is it? Exactly. All of these are hydrogen because the protons are what define the element, right? So all of these are hydrogen. Great job, great job. So we answered those two questions. This is called an isotope. An isotope is the same atom because the protons stay the same, but different number of neutrons, right? So an isotope means, okay, the proton number is the same, so it's the same element, but yet the neutron number is changing. So what do you think is going to change? It's not going to change the atom, right? They also do all have the electron on top. Great job, Megan. Yes. So when you go from the first one to the second one to the third one, yes, great job. I'm so proud of you, Kayla. That's exactly what I want to see. The weight is going to change, right? Because remember, you add up everything inside. So do you see how the weight is getting bigger? And so you average all of them out when you see the mass at the bottom on the periodic table. It's called the average atomic mass of all of the isotopes of that element. So the mass is changing for these. So I just kind of noted some of this stuff here, like one proton. So if you're kind of confused about that, I've got that notation there. The proton number is always the atomic number. Okay, so the atomic mass of this first one here, what would the atomic mass of this be? Remember, mass is protons plus neutrons. 1, right? Because there's 1 proton and 0 neutrons. Okay, so the way that we name it is we call it hydrogen-1. What is the atomic mass of this next one here? What do y'all think? 2, right? So we're going to call this hydrogen-2. And what about the third one? 3, right? And we're just counting all of the stuff on the inside, protons plus neutrons, right? So its name will be hydrogen-3, okay? So the naming, the number at the end, when you see hydrogen-1, what does that number at the end represent? Does it represent the proton number, the neutron number, the mass? What does it represent, that number at the end? Yes, great job. The number at the end here represents the mass of that element, right? So this is how you can represent an isotope. There's a few ways that you can represent it. We're going to talk about that first way in just a second. You're not used to that way, but you can write it like hydrogen-3, or you can simplify it to H-3, just to be simple, because that's the symbol for it. Okay, so these are the 3 ways that you can represent an isotope. Remember that this tells you the mass here, right? And you can also just simplify it to H. And we're about to talk about this right now, isotopic notation. So when you have isotopic notation, this X represents the symbol. This on top represents the mass. and this on bottom represents the atomic number. So it's kind of flipped from the periodic table. On the periodic table, the atomic number is on top and the average mass is on bottom. But for isotopic notation, we put the mass number on top and the atomic number on bottom. So, for example, the isotopic notation of those three would look like this. The mass goes on top, and notice how the bottom one never changes because that's the atomic number. So it's not going to change if it's the same isotope. If you have the same isotope, the atomic number is not going to change. Does that make sense? So only the top part is going to change. The bottom part is always just the number of protons. So if it's the same element, it's going to be the same number. And if the question asks you, well, how many neutrons does it have? You can just subtract top from bottom. So like this hydrogen has 2 neutrons, 3 minus 1. This hydrogen has 1 neutron because it's 2 minus 1. You can just subtract to determine the number of neutrons for that. Okay, so that's isotopic notation. Let's practice for this real quick as we wrap up. So what do you guys think? Look on your periodic table. What is the name of this element here? Take your time. You're close, Megan. Super close. Great job. I want y'all to take a second to work around with your periodic table. They can be hard to find because there's a lot of elements, right? Okay, so this element is uranium. If you're looking on the periodic table, look at number 92, okay? And you'll find U for uranium if you're looking there, okay? So the name of this element is uranium. What is the atomic number of this element? You can find it on the periodic table, or you can find it by looking at this, because remembering what we said. The top represents something and the bottom represents something. Great job, Leanna. Great job saying it, Alina, I'm sorry. Great job, Natalie. The atomic number is 92, okay? It's the bottom part. How many protons does this isotope have? 92, great job. It's the same. Atomic number and proton number is the same. And what is its mass number here? 235, right. It's the number on top. The number on top is the mass number. Great job. I think those are, okay. How many neutrons? You may have to get your phone out for this or to do a calculator. How many neutrons are there in this one? $143. Great job. Great job. Y'all are doing so great. So that is coming from this will help you on some of your lessons. This we're not going to go through right now. It's not a huge part of the lesson, but you can look at this later if you want to. There is one more kind of difficult, and this is just a breakdown of like what's a pure substance and what's a mixture. If you want to look at this, you can just kind of see some examples if you want. But there was one kind of weird part about like naming elements, okay? You're gonna need this for that when it comes to IUPAC naming. This is from lesson 1 in unit 2 and also some quizzes and tests afterward, okay? Come back and look at this. You need this to answer that question. They ask you to like name certain elements. And so I'm gonna like work on this with y'all just real quick. So like if I want to name element 121, I'm gonna break down the number. So 121, so for 1, do y'all see how the prefix for 1 is un? The prefix for 2 is what? What do y'all see there? Bi, okay, and then the prefix for 1 again is un. And then you add ium at the end. So for element 121, the name is un bi unium. You add ium at the end. If I said element 123, it would be un bi tri ium because it's 1, 2, 3 ium. Does that kind of make sense for that on how we do that? You add em at the end and you look at those prefixes to break it down. We use this if the name has not been established yet. Like sometimes they have to vote on the name. Like if you come up with a new element, there's this whole scientific community or this board that goes in and votes on what the name is going to be. So in the time in between, sometimes we just call it like this until we come up with an official name. And then when we come up with an official name, we call it by that. So this is only used whenever the name has not been set in stone yet, if that makes sense. And then after that, we call it what it is. So that is all that I have for y'all today, but I do have some resources at the end that you really should look at if you're stuck or if you're about to take Unit 1. Okay, so Unit 1 resources, Unit 2. And then if you are stuck in Unit 1, please stay and come work with me for a few minutes before lunch, and I will help you get started on that. But I hope you'll have a great day. If you have any questions, please let me know. Stick around if you need help with if you're stuck on something in Unit 1. Eden, that is so awesome. That is so great. So you're good to go, Eden, if you want, or if you want to stay and hang and ask some other questions, you're totally welcome to do that as well. You're so welcome. I'm so glad it was helpful for y'all.